Welcome to Lab 503. In this lab, you'll be working with solid copper oxide. Your goal is to determine the empirical formula, which is the copper to oxygen ratio in the compound. First, you will dissolve copper oxide in hydrochloric acid, and then you will precipitate the copper by reacting it with zinc. Start by preparing the solid copper oxide in a beaker with hydrochloric acid. Because this lab requires 2 extra runs, it'll be more efficient if you work with both runs at the same time. This will give both the maximum amount of time needed, so it'll yield accurate results. Next, both samples will need to be dissolved by gentle heating. Gentle heating means that the knob of the hot plate should be set on about 2 or 3. You should also be simultaneously stirring the samples with a glass rod. By doing this, you can speed up the dissolving process so that it'll take less than 60 minutes, which is the amount of time the lab manual says it'll take. As the sample has dissolved, the color will change to a greenish-bluish color. Once the solution is completely dissolved, you'll need to add in the zinc strip. To prepare the zinc strip, you need to sand the strip, which removes the oxidized zinc and exposes shiny metal. The best way to do this is to place the zinc strip on a paper towel on the table. Sand one whole side of the strip against the table and flip it over to do the same until the whole strip shows metal. Try to expose as much metal as you can. It should look similar to this. Now you can drop the zinc strip into the solution. As you stir, the color of the solution will become colorless. Gas evolution, which means bubbling, will also be occurring. The manual says to wait until the gas evolution stops and the solution is colorless, but you really only need to wait until it becomes colorless before you can remove the strip. The solution is now colorless, so you can remove the strip. After you take the strip out, you can now start the decanting process. Decant means to pour the liquid out while keeping the solid in the beaker. The liquid is called the supernatant, and the precipitate is the solid copper. We need to keep the precipitate in the beaker and remove the supernatant. Slowly pour the liquid out while holding the stir rod in the front. This will ensure that most of your copper stays at the bottom. Use a wash bottle to squirt some water into the beaker to rinse any solution from the copper. After you do this, you can remove the water by decanting again. However, on the last decant, make sure to decant effectively by removing as much water before taking it to the oven to shorten the drying time. The solid copper precipitate, which is left in the beaker, has an orangish color. It's very important that you perform steps 1 through 6 efficiently managing your time, because the amount of time it takes for the copper to dry varies. If the copper is still wet in the end, then that can skew your results. So you want to make sure it's dried all the way. To get ready to place it in the oven, label the beakers with your initials to prevent mixing it up with other students' beakers. Drying will take the longest, about an hour or so. So it's very important that the copper is dried all the way so you can obtain accurate results. In the end, you have the option of weighing the copper in the beaker or transferring it to a weighing paper, like the manual says. The first method is more efficient because it will prevent the loss of copper from flying away when transferring it to weighing paper. But you'll need to subtract the weight of the empty beaker from the total. Now that you have the mass of the copper, you can finally determine the empirical formula using stoichiometry.